Hi there, welcome to our series of videos demonstrating our next generation sensor for wave and tide measurement, the WaveRadar REX². In this video, we're going to give you an introduction to REX² and what you can expect to find in the box. WaveRadar REX2s are shipped partially assembled in wooden crates. To open the box, remove the lid by undoing the 6 screws at the top of the box. The locations of the screws are clearly marked. In the lid, you'll find the weather shield kit. This provides the sensor with some additional protection from the harsh marine environment. There is also a USB stick which contains the REX² manual, wave configurator software, a quick start guide, hazardous zone certification, and the optional WaveView Connect software and manual. The plastic bag contains some extra hardware, such as the flange bushings for isolating the sensor from the mounting frame, a spirit level, and the weather shield attachments. Finally, all the relevant documentation, including the certificates of conformance, compliance, testing, the setup report, and the control drawing are provided in a physical documentation pack. Easy access to the REX² is achieved by removing the sides of the shipping crate. This requires the removal of the remaining screws either side of the base of the crate. Once the screws have been removed, the sides simply slide up, revealing the sensor, which is secured using the mounting flange here. By removing the 4 screws and washers, the sensor is released. The sensor is comprised of 2 parts: the antenna assembly and the transmitter, which are connected using a threaded junction and are supplied pre-assembled. There are 2 covers on each end of the head, one for access to the terminal block for power and data, and the other one covers the LCD display. There are 2 variations of WaveRadar REX², with or without hazardous zone certification. The version without includes a discount for those who require a sensor in a non-hazardous environment. REX² supports 4 hazardous zone certifications: FMUS, FMC, ATEX, and IECEX. Full details of the certification can be found on the REX² spec sheet. If specified with hazardous zone certification, the label at the top of the sensor here needs to be permanently marked to reflect the certification you require. The sensor is supplied with an 18-month warranty as standard, with options to extend to 3 or 5 years. Introduced 20 years ago and following almost 1,000 installations, WaveRadar REX has become the industry standard for measuring waves, sea level, and air gap in coastal and offshore environments. The REX² builds on that success with vast improvements over the legacy sensor. REX² draws an order of magnitude lower power than the legacy REX sensor, at an average of 400 mW draw from 9 to 36 volt DC input. Thanks to this low power, the sensor can easily be run on solar power, removing the need for mains power connection, and allows for off-the-grid remote installations. The WaveRadar REX² also benefits from a completely stainless steel and PTFE construction. This has improved the robustness of the sensor and will increase the resilience to the harsh conditions present in the offshore environment. Because the 2 sensors share mounting points, the REX² can be straight swapped into existing WaveRadar REX installations. The mounting flange on the REX² only has 4 holes cut as standard, however we can supply more flanges with more holes on request. Unlike the legacy sensor, the WaveRadar REX² is only available for use with a DC power supply. If you are looking to replace a legacy sensor which uses an AC power supply, you will need to consider a new power supply for this sensor. The REX² sensor uses a native RS485 digital output and does not use an analog output. This is quite different to the outputs available with the legacy sensor, which use an FSK output into a field bus modem which could be located up to 4 km away from the sensor. The field bus modem would then output an RS232 signal into the processing computer. The introduction of REX² greatly simplifies installations, with no field bus modem required. When replacing a legacy sensor, this change from RS232 to RS485 needs to be accounted for. This may involve using a different serial converter, which RS Aqua can provide if required. The raw data string format from the WaveRadar REX² remains essentially unchanged from that of its predecessor. One small change is the introduction of 2 null dribble bytes at the end of each message, increasing the message size to 19 bytes per measurement. These bytes ensure the last useful byte was transmitted correctly. Another change to consider is the status indicator for valid measurements, changing from 8070 to 8000 for the REX². The largely unchanged raw data format is compatible with our WaveView Connect software. so there are no concerns when swapping in between the two sensors. If you are using a third-party software for wave processing, it may be worth checking the software is compatible with the format changes. Powering up the REX² involves unscrewing the side cap to gain access to the terminal block within. There is one cable entry port on each side of the REX², one for the power and one for the data. The sensor is supplied with plastic plugs inserted into the cable entry ports to protect the internal electronics during transit. WaveRadar REX² is supplied without cable glands. Cable glands suitable for your deployment should be purchased separately and installed prior to deployment. The thread specification for the cable entry ports are defined at the point of order. These are either M20 by 1.5 or half to 14 NPT. For the purposes of this video, I won't be installing the cable glands. The power leads and RS485 data communications are connected as labelled in the terminal block. There is also a full description of this in the manual. For the power supply, use a single shielded twisted pair with 24 to 14 AWG wire. REX² is powered by a direct current input with a required voltage range of 9 to 36 volts, an average power draw of 0.4 watts and a maximum of 1 watt. For the purpose of this video, I'll be using a 12 volt power supply. For the RS485 signal, use shielded twisted pair wiring with a characteristic impedance of 120 ohms, typically 24 AWG. The cables can be encased together for a single cable output using one of the side ports, or they can be kept separate to use both of the ports. In the case of a single cable output, we recommend blanking off one of the side ports in order to maintain the dustproof and waterproof certifications. If your computer does not have a native RS485 serial connection, then a converter is required. For the purpose of this demonstration, I'll be using an RS485 to USB converter supplied by Avantech. I'm going to confirm the COM port in use here by navigating to the Windows Device Manager and finding the REX² connection. Once the REX² has been powered up, the LCD screen will start cycling through its startup procedure. This displays the device type, communication protocol, software revision, serial number, and finally device HART address. Once REX² has been powered up, open up the Wave Configurator software on your connected PC. I've inserted the USB stick that came with the WaveRadar REX² into my computer and opened it in Explorer. You can see the Wave Configurator software here. I'm going to move this to the desktop and then run it. Opening Wave Configurator brings up the connection menu. Check that the comms port and the baud rate are correct by comparing them with the COM settings and baud rate displayed on the LCD during startup. The standard settings are 4800 baud rate and Modbus address 246. Once these have been checked, a connection test and full connect can be run. The sampling rate and maximum range of the sensor can be user set prior to deployment, with the defaults for both configured at 5 Hz and 50 meters respectively. The sampling rate will depend on the user preference of data output, while a correctly configured maximum range will ensure accurate readings from the sensor. These are easily adjusted in the measurement settings window, though real-time data must be halted during alterations. The datum from which the sensor measures is the lower edge of the threaded ring to which the mounting flange is fitted. The device information has no user changeable settings, though the information displayed may be required for diagnostics. We'll be devoting a whole video later in this series to initial diagnostics. The spectrograph is also useful for diagnostics and allows for the visualization of returns from the sensor. The dominant return is used to determine the air gap between the WaveRadar and the sea surface, which as you can see in this example is shown as 5.48 meters. The x-axis ranges are user adjustable for improved resolution. Once configured and tested prior to deployment, the REX² is ready for the physical installation. WaveView Connect's main function is to produce statistical wave parameters from the raw range data supplied by a connective WaveRadar REX² sensor. WaveView Connect is also compatible with all DataWell directional WaveRadar buoys, as well as generic pressure transducer data. For the purpose of this video, we're going to be focusing on using this software with the WaveRadar REX². WaveView Connect will save the raw input data, generate wave parameters, and display the parameters on a graphical user interface, or GUI. The process parameters can also be output to a file or to a serial port. The wave algorithm used by the software has been fine-tuned and extensively validated in close cooperation with international oil majors, and produces some of the most accurate and reliable data available on the market. The input data is continuously subjected to configurable quality control protocols, ensuring the reliability of the data is maintained throughout deployment. WaveView Connect is distributed as two different Windows installer packages. These will install the software as either a Windows service or standalone program. The service version is recommended to be installed for use in long-term stable systems, and this is generally the preferred option. The standalone version is ideal for system testing when Windows account permissions are not available, or for when COM ports are reassigned for other applications. The service version of WaveView Connect is the preferred installation type for a few reasons. Once installed, an RS Aqua WaveView Connect service now runs on the processing computer. Windows services are available as soon as the computer is powered on. You don't even need to be logged in. This means that if you accidentally close the user interface or switch user, the program will continue running in the background with no negative effects to the data. This also makes WaveView Connect ideal for use with third-party applications, as WaveView Connect can be configured to run entirely in the background, outputting data directly into another piece of software. I'm now going to run through the installation wizard. After agreeing to the brief license agreement and choosing the installation location, press the Install button. Leave this box checked and then press Finish. WaveView Connect will now launch in your default browser window. I've installed the service version of the software here, but the installation process is exactly the same for the standalone version. The only difference when using the standalone version is that WaveView Connect opens in a separate application window rather than a browser. Before we get started on activating the license and configuring the software, you should ideally have your processing computer connected to a WaveRadar REX². The REX² should be powered on and configured. If you've not yet configured your WaveRadar REX², check out one of our previous videos where we give further details on how to do this. On the bench here I have a WaveRadar REX² connected to my processing computer via an RS485 to USB converter. After installation, we need to provide the software with a valid license file and configuration. There are three different ways we can provide a license for WaveView Connect: a USB dongle, an XML file, or via an internet login. The USB dongle is generally the preferred option, as it's the only one which is not locked to a specific machine. The license type is specified before the delivery of the software. I'm now going to show you how to activate a license using each of the three different license types. The simplest license type to work with is the USB dongle. This is as easy as inserting the supplied USB dongle into the PC running WaveView Connect. The license will be automatically recognised and we're good to go. The next two methods require us to use the setup wizard in WaveView Connect. If you have chosen to use an XML file license, launch the setup wizard and press Start. Then select the Upload a license.xml file manually option and press Next. The next screen gives you a system key. This will need to be copied and emailed to RS Aqua, who will respond with a license.xml file. Once received, this file needs to be moved to the WaveView Connect installation directory before the software is licensed. The last licensing option is to use the login. This option is only available if your processing computer is connected to the internet. As you can see, I've gone back to the start of the setup wizard to demonstrate this. This time I'm going to select Obtain a license via the internet option and press Next. This will then prompt me to enter a username and password. If you have selected this license option, RS Aqua will provide you with a username and password which should be entered here. Pressing Next will connect to the licensing service. This may take a few moments depending on your internet connection. Once connected to the licensing, select the customer name and press Next. This will show you the number of licenses available to you. Select Standard License and press Next. This will generate a new license and you're ready to get started on configuration. In the wizard, select Use this wizard to create a simple configuration file and press Next. The next step is to configure the input settings for the WaveRadar REX² raw data. A baud rate of 4800, parity of none, and 8 data bits are standard for this sensor and should not be altered. The main setting that needs to be chosen here is the COM port. The simplest way to find the COM port in use is to open the Windows Device Manager and identify which COM port corresponds to the WaveRadar REX² or serial converter you're using. In my case, you can see that this is COM port 6. The next window allows you to enable logging of the raw data strings from the WaveRadar REX². If you choose to do this, you can specify where these are saved on your file system. The wave processing setup allows you to specify how the sensor is set up and configure the timing for data processing. The sensor frequency should match the sensor's data output rate during operation. This is set by the Wave Configurator software supplied with the REX². The sensor height above datum selection is there to determine the reference point used when calculating the tide parameter. This is generally the distance from the sensor datum point to the lowest astronomical tide, but other reference points such as the seabed can be used. The processing period is recommended to be set at 30 minutes. This is a standard within wave measurement, but can be customized if required. The statistics produced by WaveView Connect will use the last 30 minutes of raw data from the WaveRadar REX² to produce the parameters. The output interval is the rate at which the parameters output to the screen, to file storage, or to a serial port. The next screen in the setup wizard is the automatic data quality control. These can be left as per the default. However, we will cover more advanced configurations in a later video in this series. After quality control, we have the option to set up the WaveView server and define the port it operates on. WaveView allows you to view the data in real time from other PCs on the same network via a browser window. It can also be configured to enable remote access to WaveView from the internet via an ngrok secure tunnel. You will need an account with ngrok to provide an authorization token for remote WaveView. This should be free for low volume users. Data can be viewed via these methods, but settings cannot be altered remotely, as this can only be done on the processing computer. We're going to demonstrate WaveView and the remote WaveView features in a later video. Moving on again in the wizard, we get the option to enable data output to a CSV file and can choose the directory that these get stored in. The next screen asks the same questions but related to the XML file output. The final page in the wizard is for setting up the serial output from WaveView Connect. The serial output is comma-separated values and is fully configurable in this window. This is ideal if you are outputting the data to another device or system. Once you're happy with all these settings, hit save and this will return us to the system status page. We can now see on this page that we have a valid license and configuration file and have details of the data that's being received from the REX² below. If I now press the Launch Now button, a new tab opens and shows me the user interface. This is currently not populated with values, as we don't have a full 30-minute window of data to process. For the purpose of this demonstration, I'm going to be using the service version of WaveView Connect, but I'm not actually going to be connected to a WaveRadar REX². Instead, I'm going to generate wave statistics using the REX simulator tool that's built into the software and generates raw data at 2 Hz. This is available on all versions of the software and can be really useful for the purpose of testing. We're now going to switch to a screen capture of the software and demonstrate some of the features of the GUI. Once your software is configured, your setup page should look something like this, with the details of your basic setup at the top and information regarding your data input below. From this page we can launch straight into the GUI. WaveView Connect has been designed with operational users in mind, so large, easy to read values are key. In the basic view, 4 parameters are visible. As standard, these are significant wave height, maximum wave height, mean zero crossing period, and tide. We can swap from the basic to advanced view using the yellow toggle in the bottom right of the window. This displays 10 parameters instead of 4, providing considerably more information on the current wave environment. As we move back to the basic view, we'll have a look at the charts. Behind each value there is a simplified chart shown in blue. This is a record of history of each parameter, allowing the user to quickly evaluate any trends present in the parameter. For example, here we can easily see that the tide levels are starting to rise. On the bottom bar in this window, there is a drop down that lets us select the time frame for these charts. Currently this is set to 12 hours, but we can easily swap this to 1 or 3 hours to get a more detailed view of the conditions and the trend. For a more detailed view of each chart, clicking once on each parameter will open a new window which shows a detailed chart along with labelled axes. Below the main parameter displays, in both the basic and advanced view, there are a handful of status boxes related to the input data. These are colour-coded and provide you with a quick indication of the state of the system. One of these boxes is the REX status code. The simulator I'm using is based on the legacy WaveRadar REX sensor, so it displays a code of 8070. For your REX² installation, you'll see a status code of 8000 if everything is working as expected. If any of these boxes are not green, it warrants some investigation. We're now going to move on and look at how we can customize this display to best suit our needs. Pressing the cog icon in the bottom right of the window opens up the configuration menu. The night mode button is a simple reduction in the brightness of the display, making the interface suitable for use in low light conditions. This feature was originally implemented for use on a ship's bridge at night time. The range settings button opens a dialog box for us to configure some thresholds for visual alarms related to each parameter. These alarms can be set on a maximum and minimum basis. We have an amber warning threshold and a red alarm threshold. When parameters reach these thresholds, the display values and background chart will change colour to match the type of alarm. I'll demonstrate this now with significant wave height and maximum wave height. As you can see, they've both exceeded different thresholds, and this is shown on the main display. This is an excellent tool if there are hard operational limits that need to be evaluated quickly. Also in the range settings menu is the option to set minimum and maximum y-axis values for the background charts. If these are left blank, then the charts will auto-scale. The Choose Parameters button enables the 4 parameters displayed on the basic view to be configured to the user preference. While choosing the parameters, all other features are disabled until you click the Save button. In order to change the parameter displayed in the box, click on the name and then select a new field from the drop-down list. For example, here I've replaced the TZ parameter with TP. The list of selectable parameters includes all of the parameters that WaveView Connect can process. Due to the software's compatibility with DataWorld directional WaveRadar buoys, this also includes directional and surface current parameters. At the time of recording, we are not able to compute either of these parameters using a WaveRadar REX² installation. The last button on the configuration menu is a link back to the sensor setup interface, which opens in the new tab. That concludes the main features of the user interface and how to configure it. Before we wrap up this video, we're going to demonstrate the WaveView and Internet WaveView features of WaveView Connect. The WaveView feature allows other users on the same network to view the wave data from their PC via a browser. We covered how to enable this in the setup wizard in a previous video. If we look in the system status window of WaveView Connect, you can see that I have the WebView server enabled and running. Next to this, it gives me a URL for accessing the WebView remotely. I'm going to demonstrate the remote viewing using my laptop here. As you can see, WaveView Connect is running and processing the simulated wave data. If I copy the WebView URL from the system status page into a new browser, the same data is displayed. If another user on the same network were to follow the link using a different computer, they would also be able to see the same data. There is also some security built into the WebView feature. I'm currently viewing this data remotely, and if I try to click the cog in the bottom right, I'm unable to open any settings. The Internet WebView works in much the same way, but can be used when computers are not on the same network. As mentioned in a previous video, this feature does require a free account with ngrok and an authorization token to be provided during the configuration setup. When this is provided, next to the Internet WebView tunnel, there is a URL which can be shared for access from outside the network. The same read-only security settings are applicable here. Please be aware that the Internet WebView link is not static, and if the service is restarted for any reason, such as the processing computer being shut down, this link will change. In this video, we're going to demonstrate the physical installation process for the REX², including mounting to a GR2 guardrail frame and connecting up the sensor for deployment. One of the standard mounting options available from RS Aqua is the GR2 frame. This is a stainless steel frame designed to attach to existing guardrails of existing spacings. Alternatively, REX² can be affixed to any frame with mounting points that correspond to the sensor's circular mounting flange here using 4 bolts. Drawings of the GR2 frame and the mounting flange are available from RS Aqua on request. There are 3 main stages to installing a WaveRadar REX² with a GR2 mounting frame: affixing the frame to the guardrails, running the cables through, and mounting the WaveRadar REX² in the frame. We will now walk through all of these steps, explaining the finer details as we go. Ensure you have all of the components ready for assembly. A full list of the parts supplied with the GR2 frame will be on the screen now. The GR2 guardrail frame has been designed for use with guardrails of standard size. These are 50mm in diameter and are spaced 350mm apart. The GR2 does have some flexibility in its mounting points, which allows for some variation. The GR2 is supplied in kit form for ease of transportation and allows the user to assemble as a left or right-handed hinge system, which should be determined prior to assembly. One person can easily handle all the individual components, but two people should carry out the final installation of the beam to the pillar or use certified lifting equipment. The first step is to lay out the horizontal beam and the hinge mount on a suitable level surface. These components are affixed using 7 bolts and nuts. Before tightening the nuts fully, ensure the plate edges are perpendicular to the horizontal beam. For the assembly, you'll need the long plate, which is at the back here, and the short plate. The direction in which the long plate points is the maximum angle which the horizontal beam can swivel to. The next thing to do is to attach the vertical pillar to the inboard side of the railings at your chosen installation location. For today, we've got our muck-up rig outside the front of RS Aqua's workshop. To do this, align the brackets on the pillar with the heights of the railing, as you can see that we've done here. Then, using the screws, washers and nuts labelled on the screen, attach the back plate so that the pillar is firmly affixed to the railing. Make sure to tighten these evenly to ensure alignment is maintained. Once the vertical pillar is in position, fit the hinge using 3 bolts, nuts and washers from the bag listed on the screen. Now that the hinge is in place, we can fix the horizontal beam to the vertical pillar using the remaining 3 holes on the hinge and 3 more bolts and nuts. Ensure that the beam is supported as the bolts are tightened and that the assembly is as horizontal as possible. The next step is to attach the REX² mounting plate. The easiest way to do this is to loosely attach the bracket to the plate using the required bolts and then slide the plate over the end of the beam. Once in place, secure the plate using the appropriate bolts. Now the GR2 frame is fully assembled, we can attach the WaveRadar REX² sensor. The WaveRadar will sit in the mounting plate and will be constrained by the cutout. Align the head of the REX² so that the LCD screen is facing the guardrails. Prior to fixing the REX² in place, we need to install the supplied flange bushings. These are provided to isolate the sensor from earthing ground loop issues and prevent corrosion between dissimilar metals. One bushing should be installed between the flange and the frame, with another between the frame and the securing bolt. There should also be a large diameter washer fitted on top of each upper bush to prevent damage. We're now ready to run cables up to the sensor mounting point. Now taking the sensor end of your cabling, run this on the underside of the horizontal beam of the GR2. If possible, give yourself some extra length. This can be pulled back through once the installation is complete. RS Aqua recommends using double loop cable ties. In our previous video about sensor setup and configuration, we discussed the requirements for wiring used in the REX². We're going to be using a single cable port for this demonstration and we'll be blanking off the second cable port. Prior to wiring up the sensor, slide the cable through the cable gland. For the purpose of this demonstration, I've installed an M20 by 1.5 cable gland. I'm now going to wire up the terminal block as per the previous video. The next thing to do is to screw the cable gland into the cable entry port. When tightening the cable gland to the sensor, apply PTFE tape or other sealant to the thread. When connecting the power and data cabling, it's recommended that a drip loop be factored into the cable run to prevent water seeping into either end of the cable. If your installation involves long horizontal cable runs or cables being fed from above the sensor, definitely factor in a drip loop in to ensure proper drainage of water away from the cable. Finally, the terminal block cover can be attached and tightened. Check that the cover jam screw has been fully threaded into the housing before tightening the terminal block cover. To ensure the cover is fully engaged, check that there is not a gap between the cover and the housing. For hazardous zone installations only, turn the jam screw anti-clockwise until it contacts the cover. Then turn it another half turn anti-clockwise to secure the cover. The last thing to do here is to install the weather shield over the sensor to provide some additional protection from the harsh marine environment. The weather shield can only be installed after all the cables have been wired up and the terminal block cover has been closed. The two halves are simple to attach using the 4 screws supplied along with the top clip. Spare weather shield screws are also supplied in the box. The 2 shells fit together as shown, and the top clip slides on from the back to line up with the fixing holes. The screws can then be pushed through the holes till they meet and are tightened with a flathead screwdriver. The screws will click as they reach their full extent, but make sure not to over tighten them. The final step of the physical installation is to fit the securing plate and lock the horizontal beam into position using the 3 nuts and bolts as shown. Once the weather shield has been installed, we can swing out the horizontal beam into its extended position. The WaveRadar REX² can then be powered on and will begin to output data via RS485. Once power is applied to the sensor, you'll be able to see the LCD screen turn on, go through its startup procedure, and begin to display distance measurements. This is a good quick check to see that the sensor is measuring the sort of distance that you're expecting. For more information on the WaveRadar REX² and the GR2 guardrail frame, please follow the links below. Thank you very much for watching.